Morning to everyone, and welcome to the webinar session we're going to have on a subject which is called Energy Performance Contracting Models. My name is Rodrigo Morel. I'm General Manager of Creara Energy Experts. Just for you to know, Creara is a company which is 100% focused on energy efficiency services to companies, institutions, and any other large consumer of energy. Basically, we've been in the market for the last 10 years, and this has given us a good knowledge on how energy markets work, and basically a very interesting subject like this, energy performance contractings and the ESCO markets, which hopefully will be interesting for you. Let's get started with the session. I hope it's interesting for you all. Let's move to the next slide, to the first slide. Well, what are we going to see today? The presentation will go from general concepts, basic definitions and concepts that we must have in mind, to specific and particular contracting models with all the specific clauses. This way, by the end of the session, we should know what an ESCO stands for and the main energy performance contracting models we might find in the market. Let's go to the next one. To put all of us in context, well, energy efficiency in the framework of the European Union is considered a very valuable means to address some of the key challenges the European Union is facing. Basically, it's facing dependence on energy imports, scarcity of energy resources, the need to limit climate change, and the need to overcome the economic crisis we're just passing by. In this context, there are two concepts which we should manage, and both have been defined by the 2006/32 EC Directive, which is energy service and energy service company. Basically, energy service stands for a combination of energy and technology within a contract. Basically, these two things are provided by a third party, and this third party, the work done by this third party usually leads to energy efficiency improvements. Okay, that would be energy service. On the other hand, we have energy service company. That would be the company that delivers energy services. There are two concepts which are critical for an ESCO. One is usually these energy services, well, by all means, are delivered at the client facility, and there has to be some risk which is assumed by the ESCO, basically because a part or all of its payment is based on the energy performance. Okay, we will get in depth this concept in the next slides. Well, as we've mentioned, energy is a quite critical issue within the European Union. Unfortunately, there are still many, any country has its own market. There is not a common market for energy, but there is a direction, a common direction within energy and energy consumption. The EU aims to promote a real market for energy services. This is a reality in several EU countries, mostly Northern European countries, and other worldwide countries, like for example Canada, which it has a strong energy services market, or some states in the United States. Specifically, the 2012/27 EU directive, which is called Energy End Use Efficiency and Energy Services. So within the title of the directive, it is included the concept of energy services. This directive includes a mandate for member states to promote the energy services market. And these markets should be promoted via several ways, through improving information, exchanging best practices, publishing guidelines, publishing model contracts, promoting energy service contracts with the public administration, mostly in government buildings, municipalities installation like street lighting, etc. One of the things which is stated in this directive is that each government has to refurbish 3% of its public buildings every year. And one of the ways of doing this is by ESCO projects. Okay. So within the regulation, which is being transposed to different countries, energy services is really present. It's a reality, and it's a market which is being promoted from the European Union. That would be the message up to now. Now, once we've seen this legal framework and the main definitions, let's get in depth in what an ESCO can do, usually does. There's a whole array of services an ESCO offers to its customers, which should cover the whole process for improving energy performance of a specific premise. We can list them, but ESCO services cover several phases. Let's say the analytical phase, the financial phase of a project, implementation, operations, and then one very specific concept that we will get in depth, which is energy savings guarantee. In the analytical phase, usually the ESCO will provide in-depth diagnosis about the state of the customer facilities, and a technical and economic feasibility study of energy efficiency measures which can be implemented in that facility. The financial phase is something which is as well critical from ESCOs. The ESCO can provide either funding the renovation of customer facilities, or providing support to search for proper funding. As we've mentioned, during the implementation phase, usually ESCOs execute the implementation of the measures, and usually they will be operating the installation for the duration of the contract. The point that we mentioned before, the critical point, is that the ESCO provides an energy savings guarantee. I'll get into that a little bit later. We can consider that the ESCO can work under two types of goals. One, let's say, providing same level of energy service at a lower cost. Okay, same at less cost. An example would be, let's say we replace a boiler for a new one which has a better energy performance. Now we would be providing same level of comfort, same level of energy service, but with a lower cost. Okay. The second option, second goal is, well, we can provide a better level of energy service at the same or even at a lower cost. Okay. That would be in cases where new technology can improve current level of comfort, current energy services. An example can be, for example, if we replace a street lighting system from sodium vapor, which is this yellow light which doesn't let you appreciate pretty well colors, and you replace it for LED lamps where you have a much better quality of colors. Then you are improving the energy service, and probably you're doing it at less cost. Okay. Now, as we mentioned before, what's an energy savings a guarantee? It's also called energy performance guarantee. Now, the ESCO is going to invest in renovating the facility and gets paid with the savings achieved. Okay? Partially or totally gets paid with the savings achieved. That's the concept of the energy savings guarantee. That is one of the things which makes ESCOs different. They assume the risk, and some part of its payment is based on achieving a certain amount of energy performance. Okay. I think this slide will give you a better understanding on how the ESCO works. And I like it because we can see something which is similar to an ESCO, but then think of the differences. Basically, ESCOs can be assimilated to turnkey service. Okay. Basically, the ESCO is the single stakeholder which coordinates both with the final customer and with a list of providers on the other side, right? As you can see in the right hand of the slide, the ESCO stands between the customer and the whole set of providers. Okay. This facilitates things for the customer because on the other case, which is the left-hand side, they have to deal with all these different providers. Well, this would be the similarities of an ESCO and a company that works under turnkey models. On the other hand, when you provide an energy savings guarantee, so the payment you receive is based on achieving a certain amount of energy performance, that's unique for ESCO. So that's what makes the ESCOs different to a turnkey company. Now, we've talked about some particular examples previously about what's the ESCO's scope, where they can act. Basically, anywhere where there is energy consumption, so it's very horizontal. Any sector is potentially a client of an ESCO project. It can be an airport terminal, it can be a street lighting facility, as we mentioned, it can be an industrial plant, it can be, and it's a very common sector with lots of experiences, generation facilities, which are better operated by ESCO companies, like, for example, a cogeneration unit, a solar thermal plant, etc. It can be, for example, district heating networks. It can be a set of school buildings, military buildings, anything. Most sectors are potentially clients for ESCOs. Main areas of interest, I would say, buildings with heavy consumption in few locations. Let's say, for example, a hospital is a very good customer for ESCOs, or installations where we can find disruptive technology. For example, street lighting. Now there is a technology which has much better performance than the existing ones, which is LED. Then this is a very interesting market for ESCOs because they can invest in these projects and get returns. Now in this slide we can see a chart which explains bottom up the different types of contract models. Down at the bottom we can see primary energy provision, this is self-explanatory. This is the primary energy we use in providing final energy. The second one would be final energy supply, which is the classic service of a utility. They provide, for example, electricity, and well, this electricity is measured at a meter. This meter is at the entrance of our building. It can be a smart meter or not, and basically what we pay is we pay for the electricity that gets into this meter. Okay, that will be the definition of energy supply. Okay, now if we go up to the third model, energy supply contract, this would be the first model of energy an energy service. Okay, the two models at the bottom are basically energy supply, but the third model is the first, which is energy services in blue. This is called energy supply contract, ESC, and this stands for a provision of useful energy. Okay, what is useful energy? The energy that goes into work, which is as opposed to being lost as heat, for example. This means the ESCO needs to operate the installation to sell useful energy as an energy service. So if we have this picture of the building, the energy supply is the energy which gets into the meter, and the electricity charges us for that electricity. If we are under an energy supply contract, the utility or the ESCO would be selling useful energy. So, for example, in a building, the ESCO would be operating the boiler room and would be selling us useful energy. So this meter would be just after the boiler, okay, the whole boiler installation. This would be the main difference between the energy supply and energy supply contract. And then the last model, the one in red, is an EPC model. This we're going to see it in detail, but this is not only providing energy, but providing energy with a energy performance guarantee. We have these two models defined in this next slide. ESC, like basically in an energy supply contract, what we have is a better operation of the energy supply installations, whereas in the EPC model we have a contractual arrangement in order to provide one or more energy efficiency measures, and the savings that we achieve should be verified. The ESCO services, whether it's work, it's supply, or it's supply of goods, or it's service provided, these services are provided according to the level of energy efficiency achieved, okay, and are paid for as well. If you achieve better energy efficiency, you would be paid better. Okay. Let's get in depth into the different EPC models. Well, just let's recap. I like the definition you have at the bottom because it's interesting. We're just talking here about a creative way of financing capital improvement, so that we get funds for energy upgrade from cost reductions. Okay, this is a simple, but I think it's quite visual definition. A creative introducing creative financing in the engineering world for reducing energy costs. Here we can see also a visual explanation of the EPC contract. At the right-hand side, you have these three balls. What we're going to provide to the customer is the implementation of energy-saving measures. This is going to generate economic savings, and that would give us financing in order to pay for the funding provided by the ESCO company. Okay, which are the benefits? There are some clear benefits of this model. First, usually savings are guaranteed. When a client is thinking of should I install a new boiler or not, you always have the doubt, well, will this generate the savings that the provider of the machine is telling me this is going to generate or not? Well, the ESCO will guarantee that yes, you will reach these savings. So you really hedge against that risk. And basically, you have better operations because this is in the internal need of the ESCO. They need to operate it perfectly well in order to get to optimize its energy consumption and get paid for it. Let's see how these EPC contracts work within time. Now, in this chart, you would have at the x-axis, we have the timeline, and vertically, we would have the costs line. Okay, and what we are seeing. At the top, let me point in. We have this energy baseline. So this is pretty usual. Usually, cost evolution tends to ramp up within time. At a certain point in time, we set up an EPC contract, which would be this moment in time. Okay. From that moment, what's going to happen? Costs lower due to energy efficiency measures, which have been implemented by the ESCO. So real cost would be at this level for several years. But a certain part of the whole savings we have achieved has to be shared with the ESCO in order to pay for its work or for the goods it's supplied or for the services provided. Okay, and once this contract has ended, once the contract has ended, 100% savings return to the client. So the key issue in this model is well, the key issue, the difficulty on these models is to really establish this energy baseline. It can be easier in some facilities. Let's say, for example, a street lighting facility. It's easy to think what's going to be the energy baseline within the future, because you can say the street light facility is turned on 4,000 hours a year, and it has this total power, so you can really make it an easy calculation to have the baseline. But it's not that easy, for example, let's say in a hospital where you don't really know what's going to be the weather, what's going to be the occupation rate of the hospital, and what's going to be the number of surgeries you're going to accomplish, etc. Okay. And well, I would like to point out several key things of ESCO contracts, or usually pretty common questions. One of them would be the ownership of goods installed, goods implemented at the customer's premises. Who owns these goods? In most of the countries, local regulation says that this belongs to the ESCO for the whole duration of the contract, and then it passes to the customer. But there are some exceptions. The most common definition is that these goods belong to the ESCO. And regarding duration, this really depends on the services provided. Whenever there is an investment done by the ESCO, duration is usually long, up to 10, 15, even 20 years. And if the ESCO just provides services, usually the duration of the project is shorter. It's around 4, 5, 6 years. Now, I am going to present you now the models. Models. Now, we're going to see two models: the shared savings model, shared savings contract model, and the guaranteed savings contract model. Shared savings. What does it mean? Under this model, the investment is assumed by the ESCO, so it is the ESCO that invest in the installation of new technologies. All the engineering works are conducted by the ESCO, and of course the ESCO would manage the installation, would operate the installation for the duration of the contract. Well, main benefit is that the client benefits at the first moment of enjoying a new installation, and usually it gets part of the savings. So if we have in mind the chart which we saw before, one big part of the savings is returned to the ESCO to pay for their investment, but the client gets a little bit of these savings. And you can see the picture here, which is pretty clear. It's the ESCO that gets the financing, and both share the savings. If we go to this chart, you can see it here with under the three potential scenarios that we can see. If the real cost, what we have here at the top of the chart is the current energy cost, and there are three scenarios where expected energy cost is the same as the real one achieved. When under scenario 2, the real cost is even lower than the expected, and this in scenario 3, so we're performing better than expected. Here we're performing worse than expected, so real cost is higher than expected cost. Okay, under the first scenario, the red chunk is the ESCO benefits, which are dedicated to repay their investment, and there's this brown part would be the part of the savings that get to the ESCO, and the part at the top would be the part of the savings that get to the customer. Okay. What happens if the savings are higher than expected? Well, this part would be an extra benefit for the ESCO. Okay. But on the other hand, if the performance is worse than expected, the ESCO would get less money. Anyhow, they have to dedicate this red part to repay the investments. So the benefit of the ESCO would be really, really thin in this case. Well, shared savings is a common type of contract for public sector usually, because they're not that willing to invest themselves. Well, and it's attractive also for ESCOs because the amount of contracts are higher. Usually it excludes penalties because they're assuming quite a high risk in investing in the customer. The problem for many customers is that they don't want to sign contracts at such a long periods. For example, let's think of industrial facilities. They cannot sign contracts they're not willing to sign contracts for more than 5, 6, 10 years. That would be a long period for them. So they're reluctant to these models. On the other hand, we have the guaranteed savings. Okay, basically under this model, the investment is assumed entirely by the customer, and the ESCO's work would be to ensure real savings. If these savings are not achieved, the ESCO would be penalized. They should pay a penalty. So the ESCO is assuming part of the risk, so it gets rewarded for this. Okay. Basically, this comment we have at the bottom is pretty important. In both models, both shared savings and guaranteed savings, the ESCO is going to generate and guarantee the business case. But the main difference is who is making the investment. Now here we would see, as we've seen before, the three scenarios we can find under guaranteed savings. We have the current energy cost. This would be the expected at this level, and then we have scenario 1 where we match the real cost is equal to the expected cost. Here we would be having a real cost much higher than the expected, and under the third scenario, real cost would be lower than expected. Okay. Now, as we've said, the investment is carried out, it's done by the client, either with its capex or it can finance it otherwise, but it's not the commitment of the ESCO. So this orange part is the savings that return to the client because they will use it to repay the investment. Okay, and this red part is the payment that gets the ESCO for all its work of building the business model and providing energy services, engineering, etc. Okay. What happens under scenario 2, where real cost is higher than the expected cost? Okay, Now, the client is not going to be able to finance the investment with the savings, so the ESCO will be penalized. As we can see here, the ESCO, would be the ESCO payment to the client because guaranteed savings are not achieved. So as we can see, the ESCO is assuming the risk of not achieving this level of savings. Okay. Under the scenario 3, there are extra savings because we're performing better than expected. So then there will be an extra money, extra remuneration for both the ESCO and the customer. This model is attractive for both parts. First, the duration of the contract is lower, and whenever the calculation of savings is not extremely difficult, the ESCO is quite covered. This this model is best suited for for example, industries, SME customers. It's used also for operating generation facilities, etc. Now, these would be the two theoretical models, but as you can imagine, it's pretty common to have a mixed or blended models where the customer and the ESCO sign a contract which include both guaranteed savings and shared savings. Okay, the ESCO would have to guarantee savings to the client, a certain amount of savings, and then once these savings are achieved, additional savings will be shared between the ESCO and the customer. That would be the model. So the first part of the saving, let's say I imagine that changing a boiler room can provide 25% of savings. Okay, we can guarantee instead of 25, 20% to be conservative, but then any extra, and the ESCO would be happy to guarantee this 20% savings, but any extra savings that we get, we can share it. Okay, that would be an example of a mixed savings model. Under these models, usually the most common one is that it is the ESCO making the investment under this mixed model, but there are exceptions. Now, this would be again the chart explaining this mixed model. We've got the current energy cost, the three scenarios performing as expected, worse than expected, and better than expected. Now, what we have is as well the part that is paid to the customer as a share of savings, and this part here will be the ESCO amortization and the additional ESCO benefits if savings are more than expected. This we have it under this scenario. Okay, so this model has things of both of them, with the first part of the savings which are guaranteed, and a second part of the savings which are shared. That first part of the savings usually are not shared, are just guaranteed. Well, we've mentioned before, EPC contracts can be applied to different type of projects. We've mentioned some of them, lighting replacement, chillers replacement, boilers replacement, CHP installations, envelopment improvement measures, Uh, this is common in Northern European countries, not that common in Southern European countries because uh, we, the payback periods are pretty long. And also, as we mentioned, all these EPC models are quite common in generation installations. It can be wind turbine, solar thermal plants. It can be um, CHP, as we mentioned, and in many cases, mostly if we're talking about building, these models include a combination of energy performance measures and energy efficiency measures. Well, now we're going to get into the detail of the development of these contracts, how they are conceived, and how they work until the project finishes. Now, there are two clear stages, what we've called the pre-contract stage and then the implementation and operation once the EPC contract is signed. Well, the pre-contract stage um, has several phases. First, commercial stage. There's usually a quick scan in order to see how the facility is and what's its energy performance potential. This usually ends up in a pre-contract where you establish what the work you're going to do until you sign the final EPC contract, and you solve all the questions and the doubts about the contract model. And then in the implementation and operation phase, you would have the implementation of energy saving measures. Usually you do some recalculation once the contract is signed in order to be sure of all the numbers, and then you need to operate the installation and do the energy management of the installation in order to maximize savings. And usually at an annual basis do measurement and verification in order to calculate real savings, and can calculate the fees for the ESCO and the savings for both the ESCO and the client. If we get into detail of these both stages, under the pre-contract stage, we said we have a first stage, which is the sales stage, the commercial stage. Usually, I would say this pre-contract stage takes between 1 year and 1 year and a half, depending on the customer and the difficulty of the technology we're trying to sell. But these contracts are not easy and quick to sign because these projects have many particularities. At this commercial stage, the ESCO is going to introduce the energy services. Usually you will sign a first agreement. It can be a memo of understanding. It can be a framework agreement where you explain the whole process. There is no economic compensation at this stage, but there is an agreement to collaborate in order to analyze if there is potential for an ESCO project or not. Right after this, we would go to the quick scan phase, where the ESCO is going to request for some energy data, and we do a qualitative analysis, a quick analysis, in order to see if there is potential or not. This is called a walkthrough audit walkthrough energy audit in the United States. The energy audit you generate just walking through the installation. Now, once we have these first numbers, usually you present them to the client, and saying, okay, there is potential or there's not. If there's not, we're done. But if there's potential, usually you sign a second agreement in order to provide a feasibility study. This feasibility study, there are two alternatives. Either it's priced and the client pays for it, or and many times, well, it's priced and the client will pay for it just if the ESCO is not, if the EPC contract is finally not signed. So you can provide this project, this feasibility study, and you will get paid for it if the client finally does not sign the EPC contract. This feasibility study will include site visits, measurements, all the technical and financial analysis, so that you have the roadmap of what the EPC contract is going to include. And finally, at the implementation and operation phase, well, first thing, as we mentioned, would be implementing all the saving measures we've calculated. Sometimes we will do some recalculation in order to be sure. You need to do the request for queries to different providers, negotiate with them, and get the procurement of goods, engineering works, and the implementation of the saving measures, whatever it is, changing the lighting system or replacing the boiler, the chillers, etc. Okay. Usually, ESCO companies work with experienced companies. Now, the procurement process is pretty different. Here, the ESCO is going to look for experienced providers with reliable equipment, not the cheapest one, but the most reliable at an affordable price. Okay, so this changes a little bit the market that manufacturers are used to. Okay. Usually, the ESCO is going to sign extra guarantees for the equipment. If the contract is going to last for 6 years, 10 years, they would like to get extra guarantees signed. Now, the ESCO is going to do the operation and maintenance of the installations. It will do preventive and maintenance, and it will implement the tools needed to be sure to ensure an adequate operation of the facilities. And it will provide also energy management. So what it is? Well, it's a systematic approach of energy control, including, for example, censoring and monitoring energy consumption, providing solutions to any deviation that we might find, being daily dedicating time and effort to improve energy management of the whole installation. And the last phase of the last work is we need to provide measurement and verification. Usually this thing can be done either by the own ESCO, or the ESCO will do its measurement and verification. Sometimes the client is going to hire an external firm to provide independent measurement and verification. This stands for calculating what the savings are, and for that you need to know how the installation works, what was the baseline before the ESCO project was implemented, how consumption has evolved and calculate which are the real savings. Okay, this calculation has some science, so it needs to be done according to a process. Okay, and this would be the basis for either well, calculating which are the savings, and if the contract is under a shared savings model, which part of the savings goes to one side and which part of the savings go to the other side. If it's under a guaranteed savings, the measurement and verification will allow us to calculate if the ESCO has achieved the guaranteed savings or not. And that will be all for today's session. Thanks for your attention, and goodbye.